being here today. My name is Marie Russo, and I'm the HR Director with EGI. On behalf of the Barensfeld family and all of ELLWOOD, welcome to High School Engineering Day. You're going to have a lot of great activities today. You're going to be taking tours of 3 of our industrial facilities here in Newcastle. You're going to have an opportunity to have lunch with engineers and then hear a presentation from 2 of our metallurgists. Throughout the day, please feel free to ask questions of our engineers about the classes they took, the schools they attended, to help them prepare to be engineers. You can also ask them about projects on which they work and what they like about working at ELLWOOD. What makes us an employer of choice? So the purpose of today's event is to help give you more information about engineering jobs, specifically here in Lawrence County and especially at ELLWOOD. I want to offer that our owner, David Barensfeld, to say a few words to the students.
Thank you for setting this up, Marie, and thanks to the School to Work program, Linda, for getting this set up so nicely. This is important for us. We're going to be here, we've been here in Lawrence County for 109 years now, and we're going to be here for another 109 years. So we need new people, we need good people, we need people who want to work as engineers and to manufacture important things in Lawrence County. I'm the old guy in the room, and I'm a testament to our longevity, I hope, and I would like to recruit new people like yourselves into our business. We have our new Chief Executive Officer here, Ben Huffman, and he's going to say hello also.
Thank you, David. Well, good morning, everyone. Thank you for being here today. I think engineering is just a phenomenal career, and if you think about how all of us got here today, but for engineering and engineers, we wouldn't be here. When you got up this morning and you turned on the light, when you took a hot shower, when you got in your car, when you crossed the bridge to get here, these are all disciplines within the field of engineering. And so I applaud your interest in it. I assure you that if you work hard in this discipline, you will all have very bright and prosperous careers. And so I would encourage you to stick with it. The science of engineering, the science and the mathematics and everything that engineering involves is the reason all of us have the high quality of living standards that we have today. So appreciate that. But without manufacturing to take an engineer's ideas and turn it into a product or components for an ultimate product, we wouldn't have airplanes, we wouldn't have automobiles, we wouldn't have the things that we use each and every day, GPS. Some of you probably use Google Maps to get here today. That involves the science of engineering, and then of course you have to make the products. And ELLWOOD Group is a manufacturing company, but it's steeped in tremendous amounts of engineering, metallurgy, mechanical engineering. How do you make a product? How do you take a drawing and turn it into a component that ends up in an airplane? I think you should be really proud to be here in Lawrence County today and in Newcastle. This facility that you're in is known throughout the world. We make some of the highest quality, toughest, highest strength products on the planet. People in our industry know ELLWOOD and right here in Newcastle. What you'll see today between steel making, open die forging, machining, heat treat is making components that are going into airplanes. So when you take off in an airplane and are flying in an airplane, know that ELLWOOD likely has components either on the wings, and what's more important than flying an airplane, it's landing an airplane safely. And we have landing gear materials on those airplanes. We have materials in the braking systems of those airplanes. Not far from here in New Wilmington, we have a distribution center that distributes plastic mold steels that are produced right here in this facility that are being used by Ford, General Motors, Honda, Tesla to make the cars that we drive and likely came here today. SpaceX, everybody's heard of SpaceX. Within ELLWOOD, we're making components for the propulsion systems for SpaceX. So you think from an automobile to going into space to flying around the Earth to turning on your power, that's happening right here. So you should be very proud that your friends, your community, your neighbors, your family are working right here to produce some of the best products in the world. And as David said, we've been doing that for 100 years. We want to do it for at least another 100 years. And that's our commitment and obligation to all of you and to your families, that we want to be an employer of choice, providing high quality, high paying jobs with good benefits for the next 100 years. But we need your help. So as David said, we hope that we can grow the company, create positions for all of you in the field of engineering. Engineering is not for everyone. There's a lot of technical schools, whether it's driving large equipment, whether it's electrical electricians, whether it's machinists. Very, very large number of technical jobs out here in the facility. If you choose not to go to college, not to be an engineer, I would encourage you to check out the technical schools. There's a lot of high-paying jobs right here in Newcastle and will be for many, many years. And so I would encourage you to pursue those opportunities. In summary, please ask questions. As you're going through the shop today, ask questions of your tour guides. Remember, be safe. Good luck to all of you today in your presentations. We're looking forward to it, and thank you for being here.
Okay, this year we're doing a little bit different. So we did videos. We asked you to do videos. So we're going to ask the schools to come up. Neshannock is going to go first. And if you can come over here, and the teacher's going to introduce the students. And then we're going to show the video. And then if there's any questions, they'll take questions after that. And bear with us. We don't anticipate any technical difficulties. But if we do, just bear with us. And Renee's tried to ensure that the sound will be consistent. Some of it's a little bit louder, some of it's a little bit lower.
Good morning. I'm Greg Minsky from the Neshannock School District. This is my budding engineer group here: DJ DeBlasio, Chris Galley, Ryan Holt, and Phil Scarvell. We want to thank ELLWOOD Group for allowing us to come again this year. We've been coming, I don't know how many years, 13 maybe? And have enjoyed the process every time. Our video, Phil is on the bowling team, and we wanted to make a connection to a community activity that we all know and love. And so we started looking at the pin setter and how that operates. And then as we dug deeper, we discovered how much steel is involved in castings. So that's how we made our connection to ELLWOOD Group. First time for us doing a video, so it might be a little bit rough, but we enjoyed doing that. So.
Hey guys, what are you doing? Well, after my last bowling match, I've been interested in how a bowling pin setter works, and I realized that an engineer would have to create these.
Where do you bowl at, Phil?
Well, there's no other place to bowl than Colonial Lanes, dude.
What type of pin setters do you think Colonial Lanes uses there?
Well, I'm not sure, but I think they use an older AMF E270 pin setter, and it's still very reliable. And also, speaking of pin setters, I was doing research on this and came across this.
ELLWOOD Quality Steel's website.
So Engineering Day, and I looked on their website, and they can actually make the metal molds for the plastic parts, and also use some metal for the parts and for the pin setter itself.
Probably takes a lot of engineers on the job to get from raw material to finished product just like that, don't you think?
Yeah.
I was actually looking at AMF as a manufacturing position open, and they're responsible for making their products reliable and less costly.
Interesting. What other things does a manufacturing engineer do?
They typically try to increase productivity and cut down on the cost of the materials.
Oh, what, do you know how much money that they would make per year?
Usually anywhere from 60 to 120K.
Well, that's a pretty decent salary for an engineer.
You know, like schools around here, you can get a major in that.
Robert Morris University and Penn State have programs for that.
Robert Morris had an engineering program.
If they do.
Hey guys, I've been on vacation. What I miss?
Hey.
Alright, so that's our attempt at a video. DJ was out skiing most of the time that we were filming, so we brought him in at the end. So I guess at this point we can answer questions.
Anybody have any questions for them about why they chose the topic or anything like that? You want to tell us about, a little bit more about the questions you were
We chose the topic because Phil's on the bowling team, and we tried to make a connection with engineering and that.
Okay.
Any other questions? Yes.
Yeah, so what goes wrong when my bowling pins don't all get set up? There's always one missing.
Phil, you got this. Phil's the professional.
Alright. Well, well, sometimes it's like there's a jam or something goes wrong and the pins go set down without the correct amount of pins. So sometimes it's like hey, why we always question why doesn't it always work? So but and sometimes it's always a technical problem. Sometimes it's like it's a structural thing or something might happen. So. Any other questions? No?
Thank you. Okay, next up is Mohawk.
I'm Andy Schoenberg from Mohawk. Frank Conti's our senior, and we have Ronnie Sharilla, Tyler Cummings, and Alex Boston, our juniors. These guys put in a lot of extra time because I don't actually have them in class right now, so they had to come down on their own time. We talked a little bit about what we wanted to do for the video, and we decided to do something on something that we do use in the shop. So we used something on the plasma cutter.
We're from Mohawk, and our topic is plasma cutting. What is a plasma cutter? A plasma cutter is a tool that can cut through different types of electrically conductive metals such as steel, copper, brass, and aluminum. The machine can either be run by a computer program or it can be handheld. Plasma is the fourth state of matter, which electrically channel ionized gas that frees electrons from atoms that ions and electrons can exist at the same time. It is raised to extremely high temperatures of over 20,000 degrees Celsius.
Major components of a plasma cutter. Power supply. Converts single or three-phase AC line voltage into constant DC voltage ranging from 200 to 400 VDC. Is responsible for maintaining the plasma arc throughout the cut and to regulate the current output that is required based on the type of metal being used. Arc starting console. Produces AC voltage at about 500 VAC and 2 MHz. It produces a spark inside the plasma torch to create the plasma arc, the plasma torch, to provide proper alignment in cooling the consumables. Main consumables to make the plasma arc are electrode, swing ring, and nozzle. Additional shielding cap may be used to increase the cut quality.
What isn't a plasma cutter used for? Plasma cutters are used to cut out different shapes and designs of metal that are made into creative artwork. Auto repair shops, salvage yards, and construction sites will often use plasma cutters to rough cut sheets of metal. This is our school's plasma cutter in operation.
Okay, any questions for the students? All right, good. We got Rachel.
What's the maximum thickness that you can cut in a plasma cutter?
We haven't tested the maximum thickness of a plasma cutter, but it does vary between models. You can definitely get models that will be able to cut thicker than ours, or you can get smaller, more cost-effective models that won't be able to do quite so thick material. But for what we did, we have a Mohawk M. We were only using thin material, but if you needed something more structural, have more thickness to it, you'd have to get a larger size plasma cutter. I think there was one more in the back. Yes, sir?
I have two questions. How far is the plasma tip from the actual workpiece of this cutter?
So that also will depend on the thickness of the material. Ours was about 1 inch off of the bed, but that is something that you have to program based on the metal to keep it from. You have to, based on which metal you're using, you have to measure the. You have to watch out for the temperature. You want it to be able to make a clean cut without melting and deforming the metal, but it also has to be able to get through. And your second question?
Yeah, why is it DC that's running this machine instead of AC
That's a tough one for me.
The proper response to that last question would be, I don't know, but I'll find out and I will get back to you.
Thank you.
Anna?
Where was your plasma cutter made?
Our plasma cutter was made in Colorado. It's been at the school longer than we have, so.
How much does a plasma cutter cost, like the one that's in your school?
The one at our school.
The CNC part of it cost about $12,000. The plasma cutter itself was $2,500, and then the computer system to run it.
And again, that'll vary on which model you get. The computerized system is going to cost you more.
All right. Any other questions? All right, thanks, guys. Newcastle. So they can see you. Oh my God. Can't see you.
Yeah.
There you go.
Morning, I'm Russ Carley from Newcastle High School, and I brought my crew with me this morning. D'Angelo Paxtrot, Julian Rosser, Mark Sloan, Andrew Richards, Dimitri Ruby, Zach Buzzard, and Josh Yalmasini. And the video that they're going to show you is highlighting our engineering program, some of our robotics also. I don't know if you saw the news, but Newcastle robotics team is ranked number 30 in the world. So you can highlight a little bit of that and some of the products that they make downstairs.
Hi, my name is Dimitri Ruby, and I'm a Newcastle student here with an engineering program. As you can see, we're here, we're doing it, and I'm a Newcastle student, and last year I took this engineering course, and what happened was we had to choose a problem in daily society and fix it or somehow make it better. And we chose to choose recycling. which we came up to with this cooler right here, which is combining cement and very, very shredded up refined plastic. And it increased the PSI, or the density of the cooler. It insulates the cooler way better than a regular cooler would. And it is also very leveled out to be. And now, we will go into the depth in what it looks like.
I'm a Newcastle engineering student, and I'm here in our wonderful Fab Lab to talk to you about Design and Development Year 2. So as my former colleague mentioned, Dimitri Ruby, that last year in Design and Development 1, we discussed recycling and how we can make it more efficient. The year before, we made a cooler and a more insulated and just as strong and durable. But this year, we decided we wanted to make something different out of just plastic. So we start with your average milk jug or piece of plastic, and we cut it down so that it's not as large, especially with the bigger pieces. And then we run it through our shredder. And then once it comes out the first shredder, it comes down into consistency such as this. And then if we want to do our second shredder, getting it down to a dust-like, almost powder. And then we run it through the extruder. Once it comes out of the extruder, this in its most raw form, it looks like this. This is uncut, sanded, nothing's been done to this. This is actually one of our very first things we've extruded. As you can see, it's a little burnt on here. We've gone down the line and refined it more and more. And as you see, we have a nice even blue color here. No burns, nice and smooth. And as well as this nice black, which we messed around and just put some paint on it to make it look a little fun. And just be creative with it. Then, after we put out the extruder and out of the actual nozzle, we are able, while it's still hot and moldable, we've discovered that we can actually bend it. Here, this is obviously burnt, but you can see it's at a rounded shape versus its rod. We've mixed multiple different kinds of plastics. As you can see, we've actually drilled a hole into this one, giving it a hollow inside. But that's what we do here in Design and Development Year 2, and we look forward to.
My name is Julian Ross. I'm a senior at Newcastle High School, and I'm in CAD classes. In CAD, what we like to do is we like to make different projects that could be useful. I made a remote control holder. It can hold any types of remote controls. The way we did is we designed it out on the computer in CAD and graphics, and we brought it to a laser engraver, and we cut out pieces of wood, like this one, and we molded it into different shapes that we needed to make. Like, you can take this apart and they can go back together with quite ease. Also, during the laser engraver, we can laser out different words and whatever you want, symbols, anything.
show you guys the Fab Lab.
You have a taste of what goes on here in our Newcastle engineering course.
Questions? Go ahead, Rachel.
you mix the different types of polymers or like different recycling codes in your extruder?
Well, we tend to stay with type 5 plastic. Type 1, which is your average water bottle, tends to burn very, very easily. So we kind of stay away from that. We focus on type 5. And we've noticed that as you mix plastics, the colors can, they sometimes vary, but if you mix too many, you'll just get a really dingy brown color, and it's not pleasant to look at in the back.
What are some practical applications of plastic extrusion?
Mic wasn't on. Well, some of the benefits of using plastic extrusion is it can be used to replace more so everyday items that you would find made out of maybe metals and not renewable materials. Like for instance, you can make a golf club, a hockey puck, just out of simply extruding plastic and molding it while it's obviously still hot, and you can really, sky's really the limit. You can make as long, short, wide, thin as you really want, so there's no limits to it.
Did you notice any strength difference between the recycled and the original material that you used?
Well, that was actually one of the things that we considered when doing this. We found that it retained the exact same amount of strength. It was hard to test because there was not enough weight in the school to break the cement just putting it on it. But we ran it through, we put it in a really thin beam and we tested the strength, and we found that even though there was half the amount of cement that there was as the obviously 100% cement block, there was just the same amount of strength and consistency as it was in the original.
David?
This is more of a comment than a question. But when you go out in the shop, they ask to see the big plastic molds. We make steel to extrude plastic, but also the molder, the injection molders. And we make some very big parts for that. But do you know what kind of material was used on your extrusion die that you formed the plastic?
I'm not sure what specifically it was, but I know it was steel. Our teacher, everything that we showed was made by hand. We ordered all the parts and we actually welded it together and stuff in house. And our teacher helped us with that. I'd have to ask him the specific metals, but I know that steels were used on the actual.
One of our big products here is steel used to mold and form plastic.
Anna, did you have a question?
Very yes.
Okay. Any other questions? All right.
Hi, my name is Chris Deaney, and I'm here from Riverside High School. Thank you for having us. My group here, I have Ethan, John, Chase, Angel, Cameron, Joe, and Christian. This group is actually in a bunch of different classes. They have not met until today. So we basically had a couple leaders that we put in charge of this and then delegated what we needed all the students to do. And then they got together in a Google Classroom setting, and everybody turned their stuff in, and then we just had everything comprised there, and we were able to assemble a video from there. The topic that we chose actually is forging. The reason why we chose that is because it was something that we do at the school. It relates directly to being here, and it just so happened right when it was time to make this video and do the presentation, that's what our metal shop class was doing. Some of the students' backgrounds are, Ethan and Angel actually come from the metal shop classes, the wood shop classes. We have John, who is probably knows the most about the metal shop, has our most experience. He's our senior man. He's also our returning person who was here for last year's presentation. And then from some of the other classes, most of the guys do have some experience in CAD and doing some design work, and then Cameron actually is our multimedia person who was able to put the video together.
Riverside High School is a strong industrial technology department. Classes include manufacturing and design, 6 different workshops and laboratories.
Hi, I'm Angel.
Hi, I'm Jed.
Hi, I'm Chase.
Hi, I'm Ethan.
Hi, I'm Ben. I'm a senior from Riverside High School.
Hi, my name is John. I'm a senior at Riverside High School.
Hi, I'm Kieran.
Hi, I'm Christian. Today we're going to look at the metal shop and the process of forging. Riverside has a strong working relationship with the local industry and supporting LC. What is forging? Forging is the process of pounding with a hammer or squeezing a metal, usually after it's been heated. This shapes the metal. Traditional forging may paint a picture of a blacksmith hammering a forge. Today, electric, hydraulic, or compressed air hammers and presses shape the metal into the desired color. The benefit of forging is that it strengthens the metal because the grain flow is not breaking. Forging also decreases the imperfections in the metal. This makes it stronger than other metalworking processes. Most often, once a metal part has been forged, it is later machined into a final product. History. The practice of forging can be traced back to at least 4000 BC. Forging started in Mesopotamia, where men used to use a rock and a fire to forge metal. The very first metal that was forged by fire was gold. For many years, a forging rock was used, and now instead of a rock, a hammer is used. Men who would forge metals became known as blacksmiths. The Iron Age was around 1500 BC. Then blacksmiths were the heart of every country village. Most blacksmiths forged iron or bronze. To heat the metal, early blacksmiths used wood fires to forge and later discovered that charcoal made a better fire. They would use a hammer, anvil, and chisel to shape the metal. Some popular items that blacksmiths made were swords, armor, horseshoes, horse accessories, and tools. The blacksmiths that made swords and armor were the most important to a successful village because it was an aspect that determined if the village's army was strong. During the Industrial Revolution of the 1800s, metalwork became powered and mechanized. Today, flammable gases or electricity is used to heat metal. Types. The 2 other types of forging are open die forging and closed die forging. There are many advantages and disadvantages to each of these processes to forge. Open die forging is the forging product of working between flat or simply contoured dies with unrestricted metal flow using repetitive strokes and continuous manipulation of pieces that's being worked on. It's similar to hand forging. The dies are usually simple and don't completely enclose the metal. The metal can be moved around and handled. However, they need the metal to be shaped. This is like the hammer and anvil concept. Closed die forging is the shaping of hot metal that is enclosed in the walls or cavities of 2 dies that come together to enclose the piece of metal on all sides. The dies move toward each other. The heated raw material that is approximately the shape or size of the final forged product is placed in the bottom of the die. Then the 2 are pushed together with lots of pressure. The dies are in the shape of the object that they are trying to get out of the metal. Finally, they are pushed together while it's still hot and gets molded to that desired shape. Products. The forging process helps carry out many everyday products and items you see in day-to-day life. Automobiles and vehicle parts are the most common to everyday person. Forging is used in the automotive industry to create parts such as crankshafts, rocker arms, camshafts, drive shafts, brake levers, front/rear axle, differential cases and covers, and much more for the car you drive every day. ELLWOOD City Forge. With over 100 years of experience, ELLWOOD City Forge is a global leader that produces many large products by forging. They can forge products up to 110,000 pounds, 57 feet long, and 94 inches in diameter. The forge produces some of the largest products in the industry. Some products are even used in shipbuilding, trains, power plants, and heavy industry. Riverside High School Metal Shop. Riverside High School has a state-of-the-art industrial technology department. One such class offered in metals. In the metals class, forging is one of many processes students learn about and demonstrate. The first project made using forging with a hammer and anvil is a cooled chisel. Students hammer a piece of steel into the shape and heat treat it. After forging, a belt and grinder is used to clean up and sharpen the tool. The second forge student project is a ball opener. Again, using hammers and anvils to make these items. We first start by cutting a flat stock bar. Other projects include sheet metal bending, welding, pouring into the foundry, machining with milling and turning. The advanced level classes build upon the level 1 skills. More skills are concentrated on hammering and using the anvil with more forging tools.
All right, questions for Riverside. Rachel.
What kind of defects can you have during forging?
You can have imperfections in the piece where it's like where it's like bubbled down almost. It's not completely smooth, and you can have cracks in it. You can have stress marks from it, and from the heat treating can help make it better, make it stronger.
Other questions? Steven.
Did you hardness test the chisels that you made?
Yeah, we did hardness test them. We used the Rockwell hardness tester.
How hard is it?
87.
Rockwell, what scale?
I'm not sure exactly what the scale is.
What steel did you use?
We used a high carbon hexagonal steel.
David.
I don't know if you're going to see the 10,000 ton press running. Is it running today? You know? We're going to see the 5,000 ton.
Dave, you're not running?
I think the
Presses will be running.
5,000 and 45.
So 5,000 tons, that's how much force you deliver to hydraulic power to the dies. That makes sense. How much force does a blacksmith deliver to the hammer? For the hot piece you do? How much more powerful is this press than one blacksmith? Great guess.
I don't know the exact amount of pressure that the blacksmith can put down, but I know that the press can put down a lot more pressure.
About 5 magnitudes. Does anybody else have any ideas about it?
Other questions? Go ahead, Kim.
Do you find that there is a lot of interest generated from the videos that you showed with that class with the forging? I find that very interesting that you offer that in your school. Do you have a lot of students that are interested in those classes?
Yeah, we have about, I want to say, throughout the school day, 120 kids in our metal shop classes, and all the classes are full, and everybody always wants to learn about this stuff. We take great pride in learning about all the forging stuff.
The ability to take someone's hand scribbles and make it into a CAD drawing and then produce that part, to me, is very satisfying. And it's also a skill that not a lot of engineers have, at least the ones that are coming out of college today. So it's very nice to see high school students having the ability to actually make a drawing that actually makes sense. Because a lot of engineering students coming out of college can't do that.
Actually, for my woodshop project this year, I've had 4 years of CAD, so I drew up my own woodshop plans. And so we drew them out and prototyped them on the laser cutter, cut them out, put them together, make sure they fit, and then we built it out of wood. And so it actually worked, and the finished project is pretty cool to me that I thought of it. It's one of a kind that no one else has done. I can do that from my brain to make an actual product.
It's very satisfying. It is. That's one thing I find. 2 years ago, we started to lay out the shop that's right down the road here, and now it's coming up around us. And it's sometimes very stressful, but also somewhat satisfying to see it. I remember whenever we were sitting in my office, having cut out pieces of paper, we had a floor plan, we were trying to figure out where all the equipment was going to go. And now it's being set in place, we're wiring to it, we're running pipe to it, and it's a lot of fun.
It's neat to see a thought come to real life.
Any other questions? Okay, Lawrence County Career and Technical.
Hi there, my name is Bradley Wentworth. I'm a teacher at the CTC. Today with me I have 6 students. They're from different shops at the CTC. We've got Jake Alfano, he's from Machine Tool Tech. Cody Marks, Electrical Occupations. Stormy Fiallo, Electrical Occupations. Elizabeth Enninger from Restaurant Trades. Jaden Locke, who is from our COT, Computer and Office Technology. And then our last one, Julie Williams, who is from our Health Assistant. Today's topic we're going to talk about is nanotechnology. We specifically focused on the medical end, but we also related it back to EGI, ECF, ELLWOOD City Crankshaft Machinery, by how nanotechnology is actually used in metallurgical advances. So we're talking about like nanofabrication, nanoparticles, and even the use of nanobots.
Cody Marks, I'm in Electrical Occupations at LCCTC, and we're going to present to you nanotechnology and lung cancer.
Hello, my name is Jake Bofeno, and I am in Machine Tool Tech at LCCTC, and today we'll be talking about what is nanotechnology. The word nano means dwarf in Greek, or today it means 1/1000th of a meter, which the range of it is 1 to 100 nanometers. The father of nanotechnology is American physicist Richard Feynman. He suggested that nanotechnology is the study and application of extremely small things that can be used across all science fields, including medical usage. Nanotechnology is used to create structures, tools, and devices, materials, and modern-day parts. The ability to see individual atoms occurred in 1981 by the use of a scanning tunneling microscope.
Hello, I'm Stormy Fiallo from Electrical Occupations at LCCTC, and I'm here to explain lung cancer and its effects. There are 3 types of lung cancer: non-small cell lung cancer, small cell lung cancer, lung carcinoid tumor. Lung cancer is the leading cause of cancer deaths in the U.S. among both men and women. Some of the causes are smoking, secondhand smoke, exposure to radiation gas, asbestos, and other carcinogens. And some family history of lung cancer. Symptoms: coughing up blood, shortness of breath, chest pains, hoarseness, bone pain, headaches. And some preventions of this can be no exposure, exercise, and do not smoke.
I'm Jaden Long, and I'm with Computer Mouse Technology at the CTC. And today I'm going to talk about lung cancer treatment with nanotechnology. Nanotechnology has come a long way, including advances in detection, diagnosis, and therapy of cancer. It also has a new field called cancer nanomedicine, where nanoparticles act as a drug delivery for lung cancer therapy. Nanoparticles can deliver treatments and diagnostics selectively to specific locations or tumors in the body. The first nanotechnology-based cancer drugs are already on the market, and they include Doxil, Abraxane, and Genoxyl PM. My name is Elizabeth Edinger. I am from the Lawrence County Career Technical Center. I'm in restaurant trades, and I'm here to talk about Western PA and medical nanotechnology. The Pittsburgh area has several branches for nanotechnology, even beyond medical field. Pittsburgh and Philadelphia are in high demand for medical jobs. Some of the local employers we have are UPMC for medical field, Leidos for material scientists, Pitt for research analysis, CMU also for research analysis. The average salary in PA is $46,046. Nanotechnology and EGI is used in the metallurgy of steel and alloy design, materials science specifically for metals.
Hi there, my name is Mr. Windhorse. I'm an advisor for the engineering club and also a teacher here at the CTC for physics. Today I'm going to talk to you about engineering and nanotechnology. Some different benefits, including nanotechnology and the use of nanotechnology, are everyday materials and processes, electronics and IT applications, so at the CTC, our electrical occupations group, medical and healthcare, our health assistant group, energy applications, environmental remediation, and future transportation benefits. Some branches or types of engineering involve material science, where they may use nanofabrication, nanoscience, nanoparticles, and nanomaterials. Nanoparticles are the main focus for medical use. Other branches include biomedical engineering, or BME, medical engineering, ME, or most importantly for EGI, mechanical engineering, where we create the parts used in the medical field.
These presentations include National Nanotechnology Innovative, American Cancer Society, Understanding Nano, Mayo Clinic, National Cancer Institute, and Pittsburgh Technology Council. That concludes our presentation today. Any questions?
Hey, does anybody have any questions for them?
I think you have a question.
Do you know of any difficulties in actually manufacturing something that's small?
Not sure off the top of my head, but I would assume working on atoms. Is this working? I think we need an engineer better than me. Maybe it's rare. But I'm sure using or working on atoms so tiny, there has to be error somewhere occurring. Anyone else? Sorry. Someone?
If you're interested, Pitt has an excellent nanotechnology department.
Do they?
Part of their material science department.
Yeah.
One of the professors just won an NSF award for it.
Oh, really?
And it's really interesting. You can actually put it in an SEM or a TEM and actually see these things. So if you're interested, look up some of the research.
I'm very interested. Anybody else? Back?
Just wanted to point out that you are correct that we do
mostly talked about the medical area and the nanotechnology, but it is in other aspects.
But to Stephen's point, like how you get the strength of your material is actually done in reactions that are that small.
Yes.
So you'll see some big pieces out there, but everything microscopic and nanoscale, that's actually what's getting the strength we need in these massive sections. So it might not look like, the small little structures that are made in nanotechnology, but we actually rely on it every day.
You could say that nanotechnology started like day one. The moment they started mixing paint, that is technically using or utilizing nanotechnology. Now, obviously, back then they didn't know they were doing it, but mixing paint would be like the use of nanotechnology.
Any other questions? Okay, thanks guys. Okay, Shenango is up next.
Okay. Hi, I'm Joe Merlino. I'm the STEM teacher at Shenango High School. Today I brought to you a mixture of our STEM students and our physics students. We have Brian Mover, Joe Mancino, Bryce Ensko, Sam Belozier, Nick DiMatteo, and Brandon Gold. Their topic that they chose to use was, we actually picked a specific type of engineer, we picked a safety engineer. Two of our students in our group are working on a project right now that they're actually going to go to the state level and compete for. They made a safety device for hunters, and we've actually been working with somebody from the ELLWOOD group. What's his name again?
Ben Conway.
Ben Conway. I don't know why I can't talk in front of you guys. Talk for us class all the time. But anyways, Mr. Ben Conway has been helping us out with talking to us about different types of safety aspects and how our product could help him out in his job here. So I'll turn it over to the video and go answer questions after.
What health and safety engineers do. Health and safety engineers put systems and technologies in place to reduce the actions that humans have on the environment and to ensure that the world is a safe place. They develop procedures and design systems to keep people from injury and damage to their property, to make sure that the environment we live in is a safe area for us and the animals that live in it. They also use their knowledge to ensure that chemicals, machinery, and furniture will not cause harm to people or their property. They design environments, systems, technology, processes, and procedures to minimize the potential for problems. They combine a multiple of disciplines for their field, such as engineering, research and development, and health and safety. They work with health and safety trainers to explain why and how they design structures and how they can be improved. They look at how their designs can fail and how they can fix them now. They also are proactive to see how something will go in the future so that they can prepare for it now.
Where do health and safety engineers work? Well, here's where health and safety engineers work. It depends on their background. They may be making chemicals, new technology, or health and safety equipment. Most health and safety engineers work at manufacturing plants. They could work in the actual environment, which is factories. They could also work in research and development labs to make sure those products that are made there are safe to be used by consumers. Here is some data on where safety engineers may work. 21% of health and safety engineers work in construction. Only 10% work in high government positions or roles. Now 8% of these engineers work in engineering services, and the remaining 4% work in management and scientific services.
Becoming a health and safety engineer is quite simple as for the schooling. You simply need a bachelor's degree in technical engineering or a health and safety related degree. However, if you would like to increase your pay and or make yourself more marketable, you need to earn certain certifications to make you more knowledgeable in your desired field of study. These certifications are the best way for a safety engineer to advance and become more successful. For example, earning your CSP or your Certified Safety Professional licensure will broaden your horizons as to the certain employers that are willing to hire you. A few schools that you can earn your education from are Slippery Rock University, Indiana University of Pennsylvania, and West Virginia University. At Slippery Rock, they are best known for their management aspect of safety, whereas at IUP and WVU, they are more known for the sciences and the health aspects. All of these schools will give you a great education and will make you very marketable in the years to come.
State and area data. Employment, 26,130 people. Employment relative standard error is approximately 2.1%. The mean hourly wage of a safety engineer is about $44.32. The mean annual wage of a safety engineer is about $92,190. The annual wage relative standard error is approximately 0.6%. 10% of safety engineers make $24.92 per hour, totaling $51,820 per year. 25% of safety engineers make $32.05 per hour, totaling $66,660 per year. 50% of safety engineers make $42.55 per hour, totaling $88,510 per year. 75% of safety engineers make $54.89 per hour, totaling $114,180 per year. 90% of safety engineers make $72.13 per hour, totaling $139,630 per year.
There are other similar occupations to safety engineers. For example, construction and building inspectors deal with the safety of buildings and make sure they are up to code. There are also fire inspectors who make sure buildings are free of fire hazards, and after fires occurred, they find the source of the fire. Industrial engineers who find better and more efficient ways to produce goods and services. Mining or geological engineers design mines to be safer for the workers and more efficient.
All right, any questions that anyone has for Mark?
Did you say you were working with Hunter on the safety project?
Yeah, it's actually a project that we worked on. One of the judges is here, and
The other one will be here this afternoon.
yeah, the other one is here somewhere. And yeah, we kind of did this a little bit different. We kind of did a little bit different than everybody else, but here's our actual project that we did that kind of relates to engineering and everything.
Okay, so what we did here is we made a device that goes on a safety harness, whether it be for hunters or linemen, whatever it is. And whenever you fall, it pulls a couple plugs and detects that you've fallen, calls 911 for you, texts, buddy back at camp or one go to bots or what have you. And does it all automatically, so if you go somehow go unconscious, it still calls either way. There also is a cancel button on it in case you are conscious and you're okay. You know when to please call. Brian did all of the 3D printing, and I did all of the electronics and electrical stuff.
Sam is going for safety to Slippery Rock, right?
Yep.
And Nick is going for construction management to Kent State. So that kind of helped with the decision-making process as well.
Dan, you have a question?
Why do you think it's so important that safety engineers have a technical background?
We kind of think it's important because if they don't really understand the systems that are in it, they can't really help to protect what it is.
Rachel?
I have more of a comment than anything, but safety is incredibly important to ELLWOOD. The nature of our job is dangerous, so everything can be improved, and safety is something we are constantly looking at. So I'm glad that you recognize that there's an entire branch of engineering specifically dedicated to safety.
Anna?
How did you identify fall protection as something that you use in solution of yours? How did you identify that problem to solve?
Well, we live in an area that there's a lot of hunters, and we see stuff in our lives that people will fall and they'll get hurt, and they have no way of contacting anybody. So it kind of gives them a second chance to be safe, because a lot of times where you fall, you could be unconscious. So this kind of helps people have a better chance of surviving stuff like that. Because if you're unconscious, you could lose blood flow due to the harnesses and everything. So it kind of helps out those people.
Yes.
Now, do you have to connect that to like your phone, or how would that work?
We're working on the second stages of this project right now. With Bluetooth capability, we're actually ordering the board after school today. So it doesn't connect to the phone now, but it's on its own satellite chip. So no matter where you are, it's gonna ring somebody's phone, 911, have you.
And you can set it to like who you want it to call?
Yep, all in the code. We're working on a better interface for it, so you don't have to go into the lines of code. You can, just have a drop-down menu or a type box, so it's easier for the consumer.
Would there be like some form of delay when I fall? Like the difference be like if I fell and was unconscious, I'd obviously need someone to call. But if I just tripped on a branch, I would need to call 911, alert my boss.
Yeah. So whenever this trips, whenever this goes open circuit on this connector here, there's a 30-second delay. You have 30 seconds to push a button on the harness that says, "Hey, I'm okay." If you don't push that button within 30 seconds, then it proceeds the call.
And it does actually call. When I was judging it, they actually tripped it, and it will send a text and it will call whatever phone you have it set up.
It
It's a
sends-
really interesting device. So if you're stuck in a tree, it's a good thing to have.
If you're unconscious and it calls 911, let's say you have it set for 911, and does it also send like a geolocation?
It sends latitude, longitude, raw data to 911. Lawrence County actually has a text to 911 service, so it receives the latitude, longitude, time that it was tripped, things like that. Then there's also an automated message you can record in here to call your buddies. If you're, hey, I'm out hunting right now. I fell. If you're getting this call, I've fallen. I need help.
Good question. Any other questions? Kim?
There is a lot of relevance when you think about that unit, not just for hunting. When we have cranes that are very high, and we wear the harnesses. If one of our guys was in trouble, like on a night turn, there's not as many people out that could call another person. I think there's a lot of relevance to our
Thank you.
job, guys. Thank you. Union?
Hi, my name is Joe Canciello. I'm from Union Area School District. I'm the technology director there. Our crew here is assembled from kids from all different sectors. At Union, we're pretty small, so you get to wear a hat for several different jobs. We have Arnud, who's actually stepping in for Tyler Benedict today, Kyle Cassie, Dom, Lexi, and Seth. What we did is we identified a problem, the problem being organ transplants. It so happens that PA, and Western PA specifically, is well equipped to handle this problem. Why? Two of the largest job sectors in PA would be healthcare and manufacturing. Our presentation, as you'll see, deals with 3D printing of organs, which is a field that is really just starting to move forward. So a lot of it is conceptual, and I hope you enjoy it. Thank you.
We're here from Union's team to present to you 3D printing organs. My name is Kyle Cassie.
Seth Pemberton, Tyler Benedict,
Alexander Bucker,
And Dominic Son. The history of 3D printed organs. 3D printing itself links back as far as the early 1980s. The promise of printing human organs began in 1983 when Charles Hull invented stereophology. By the early 1990s, 3D systems had began to introduce the next generation of materials, nanocomposites, blended plastics, and powdered metals. In 1999, scientists at the Wake Forest Institute for Regenerative Medicine used a 3D printer to build a synthetic scaffold of a human bladder. And in 2002, scientists printed a miniature functional kidney, capable of filtering blood and producing urine in an animal.
The use of 3D printed organs. The uses of 3D printed organs can be endless. The organs include heart, the kidney, liver structures, and many other organs. The 3D printed organs have been tested and have helped not only humans but animals too. The uses are endless in the body and will be much more cost efficient while theoretically having less issues in the future. The organs can be mass produced and people wouldn't have to donate organs anymore because there would be more available 3D printed organs. And here's a picture of a 3D printed organ.
Shortening the length of the donors. Recipients would not be forced to wait for an unpredictable long period of time. Organs of which Organs of which are not typically donated can be produced. And organs can be produced with the recipient's cells, reducing the risk of organ rejection. Immunosuppressant medications would not be needed. Making organs for all ages and needs.
organs can be produced specifically for different cases. More availability for different age groups and recipients. They can be produced quickly, even on site. Atypical transplants are now possible.
Making procedures cost less. 3D printing helps with procedure speeds. Printers cost less than $10,000. Bioprinting kidneys cost $280,000 compared to the average price of $330,000 a real kidney transplant cost. 3D printed kidneys would potentially replace kidney donation process.
Conclusion.
Any questions?
Human kidney
Well, yes, it's made of it's a polymer that's very flexible, and it actually acts quite realistically compared to a real organ. So the plastic would mold with you, and the polymers used would be more flexible, and along with that, they would grow and certain things like that that would actually like never need to be replaced, like maybe temporary maintenance, but that would be about it. Any other questions? Yeah.
Have they done clinical trials on people yet with 3D printed organs?
There's actually been several cases where it's been necessary to place 3D printed organs in people when they were too far down on the donor list. And a good example would be kidneys and other less life-threatening that you could live without as trials, such as a liver and a kidney. But there have been examples of heart transplants, and I think even recently that someone transplanted like whole limbs that have actually been able to be functional. So it's in its infancy, but the farther we get, the faster we can do it, the cheaper it'll be, and the more it would be available to everybody. Any other questions? No? Okay, thank you.
All right, Lincoln.
I'm Tom Nadal. I teach physics at Elwood City Lincoln High School. Today I have 4 students from the Honors Physics 2 class with me. I have Reese Wilson, Vanessa Huth, Bryce White, and Tayshawn Green. And our video is about bringing the space exploration back to American soil instead of using Russia and other countries to go to outer space.
And Cape Canaveral, another probe into space. Target, the moon. A 52-ton multi-stage rocket combining elements of the Thor ICBM and the Vanguard is ready for firing. Its payload, a toy, top-shaped instrument package with its own tiny rockets. This countdown has scant margin for delay. The missile must follow a carefully computed course if there is to be any possibility of intersecting the moon's orbital passage. And there is only one 15-minute go period for launching the rocket into that course. On the planned course, the 83-pound Pioneer space probe would closely approach the moon and be swung into orbit by the moon's own gravity. From its position 250,000 miles out in space, the moon probe would have broadcast back not only scientific data of enormous value, but the first pictures ever seen by human eyes of the far side of the moon. A daring and dramatic goal that was not destined to be realized on this day. 1, 0.
After the retirement of the space shuttle, we have been relying on Russia and their Soyuz rockets to get into space. NASA is paying Roscosmos roughly $80 million to ride to an international space station and back. An astronomically high cost considering what it would cost for NASA to use Boeing's CST-100 Starliner or SpaceX's Dragon crew instead. Due to a gradual cutting of NASA's budget regarding the total national budget, and a loss of interest, space exploration has become a privatized endeavor, bringing with it a new space race between the American companies SpaceX and Boeing. This is where the ELLWOOD Group comes into play. The ELLWOOD Group is listed by both companies on their approved processors and mills list. Regardless of which company wins the space race, it will be the ELLWOOD Group and its employees with their high-quality standards that will help make it possible.
Questions? Rachel, Lincoln. Yes.
What are some challenges of using steels that we typically would think of using here on Earth? What kind of challenges do you think they would face in a space environment?
Well, I don't know the answer to that question, but I can get back to you on that later.
Rachel, what's the answer?
Well, it depends on if it's external or internal, but you're looking at extremely cold temperatures where, they're incredibly extreme, so their toughness can decrease. The lack of gravity, there's a lot of different things that can go on, so.
And also, it's too heavy.
Yeah.
It's 3 times too heavy compared to titanium.
So.
Plus the radiation.
Yep, radiation. There's a lot of different things that, the Earth doesn't have that you will face out in space. So you have to make sure your materials can withstand all of that while still testing them here.
Any other question?
Well, it's kind of a statement. I don't know if you've been watching the news, but I think the Dragon crew capsule docked the ISS 2 days ago.
Yes, that's right. Just this past weekend, they launched their 17th rocket and docked into the ISS. And supposedly the next rocket will bring actual astronauts into space. Any other questions? Yes?
What kind of engineers does NASA hire?
So NASA hires several types of engineers: mechanical engineers, electrical engineers, chemical engineers, pretty much aerospace engineers. Just about every discipline of engineering is used to put every piece of the rocket together and then send it into space safely. Any other questions?
Okay, anybody have any other questions for the students about their presentations? All right, I think they all deserve a round of applause. They did a great job. Okay, we're going to show, while we're all still here, we're going to show the safety video first, and then we're going to split into 2 groups. One group's going to go on a tour, and one group's going to go to lunch. You'll have time, to take a bio break and that type of thing. But Renee, if you could just show the safety video first. Very passionate and very involved in the School to Work program and keeps that connection and the good support for this event here today.
And thanks to Marie. Let's thank Marie.
I also want to thank David Barensfeld, Anna Barensfeld, and Ben Huffman for their ongoing support of this important event. So I think everybody deserves a round of applause. Everybody did a really good job with the videos, especially this was the first time that we were doing them. We had a lot of people evaluate, and the decision for the winner is Riverside. We actually have a trophy this year. So the Riverside students, if you want to come up, and Casey can get your picture, and then you are welcome to go over and pick something from the table there.